All right, you said zinc acetate? Okay.
CH3O. You need to remember that from the test. They asked about cyanide and they also tell us.
Yeah, cyanide you don't have to know. Well, let's go off this guy first. Okay, so zinc acetate. First, let me bring up the chart with all the polyatomic ions.
Yeah, I think acetate is wrong.
To use that has a... Yeah, acetate's, it's just -1, I think.
Yeah.
So here are all the polyatomic ions you have to know for the test. Again, these are the only ones that will be on the test. This is it. These 9. So acetate's on the bottom here. CH3COO minus. So that's the charge for acetate. Yeah.
I have a question about that molecule.
Yeah.
Right. Why do you write out the 2 O's? Why can't you just say O and the 2 C's?
I don't know.
What?
I don't know. I have no
Because that
idea.
last O has a negative charge.
No.
You could say the whole group has a negative charge.
Because this is a parenthesis supposed to go around CH3COO. You know, negative is on the outside.
Sure.
It looks like the last O has a negative.
I don't know. I don't know why.
So in the
Negative
test,
on
if I
top is
put
supposed to be outside. All that is
CH3CO2,
outside.
That's wrong.
it makes sense.
If you put, I would mark it wrong, but you don't want to put that. Okay. Don't want to put that. All right. So acetate is CH3COO.
You realize simplify
Minus.
that to something so you can fit in the box?
What?
I think we like simplify so you can fit in the box.
No, simplify.
No.
Remember the old one?
Zinc. And again, in this one, based on the previous example, I'm going to assume zinc is +2. All right. That's just what I'm assuming. Zinc is +2. Normally, if you assume it's +1, that's fine. That's okay. I understand why. I'm just saying I'm going to assume it's +2.
Like, what if we saw zinc on the test? What would we do?
If you saw, let's say you saw the name zinc acetate and didn't have a Roman numeral,
Yeah.
you assume it's 1. You assume it's 1. Okay, I cannot consciously mark you wrong and be fair about that. Like when we talked about the whole assumption rule, you know?
That's true.
Well, we could say
Yeah, sure. Absolutely. Yeah, I'll take either. Absolutely. If it's just stuck in your brain now, good. Good for you. Like it's happens with me all the time where you just... Yes, person who's not supposed to be in this class? Do you have something to say? Oh, what, say it one more time? Oh yeah, absolutely. So in this case, you want to take the number of the charge and cross it. So 2 will go over to the acetate, 1 will go over to the zinc. This will become Zn1. This will become CH, not lowercase h, I don't know what I'm doing. CH3COO. Let me put in parentheses and make it a little neat. And the 2 from over here will go on to the acetate. So again, the 1 from the charge goes over to zinc. The 1 from this charge goes over to acetate. And that is the formula you can write out. There you go. Yes, Josh.
Following up question about the molecule. See, why can I not just say CHHH?
We're not going to have this, please.
CHHHCOO.
Yeah.
Why can't you say that?
Why can't I not?
I don't know.
But would it mean the same thing if I just say COO2?
I guess.
So it,
You know, I've seen it before where it says CO2. I've seen it before. Well, I'm saying I've seen it before where it says CH3CO2 for acetate. I've seen that before. So it's not wrong to put. It's just it's more commonly seen like that. Okay. Raina. Yeah, sure. Oh, Brian, hold on. Brian, what's your question?
I was just going to say that.
Same thing?
CH3.
Oh. All right, next question.
So if you put carbon, hydrogen, and carbon dioxide in a big container, if you gas it?
Not necessarily. Not necessarily. You have to, maybe if you put it under like a lot of pressure and heat, maybe, but depends.
It won't combine one.
Not exactly. All right, next question from the study guide. Travis.
Uh,
What do you think?
copper chloride.
What number is that? Number 1?
Yeah.
Copper 2 chloride? Okay. So we're trying to get the formula for this? Copper 2 chloride. All right. So Travis, what does the 2 tell us?
No, there's a 2 chart.
For what?
Copper.
Yeah, exactly. And what's the charge of chlorine?
1 is carbon.
Yeah, -1. So all you have to do is take the number and cross it. Number, cross. So that will give you Cu1, Cl2, and you don't need the 1.
So we always.
Hold on. Please don't yell over each other, Alicia. What? If it has a Roman numeral, it tells you the charge of the copper. Melissa. Yes. Yeah, basically with the crossing method, you always just find what the charge is and then cross. Charge, cross. Charge, cross. And honestly, you don't even need the positive and negatives. Like someone from a previous class asked, like, does it even matter if we know what the positive... Honestly, no, because you just need the numbers.
You just need the one in the
Yeah, like you only have to know what numbers you're dealing with. The charges are more for just in general chemistry. You're going to need to know charges down the line. Okay, Travis, do you have a comment?
Well, I figured it out from looking at.
Okay, good. Kana?
3 vanadium, 3 selenide.
Okay, vanadium 3 selenide.
That's in the chart? No.
No, now we're on number 3 on the front side.
Oh.
You're right.
What? Oh, that's 2 different. So that's 3 is vanadium for selenide.
Yeah, what's up?
Does it also say the charge of the whole molecule?
What, the Roman numeral?
No, not the Roman numeral, the highest charge. Like, back to the other example, how copper had +2. Does it say the whole molecule is a positive charge molecule?
No, the whole molecule will be neutral.
It just means
The whole molecule has to be neutral, yeah. It must be. That's the whole reasoning behind all this charge balance junk, is that you want to keep it balanced. And you'll see that here. So vanadium, we know, is a 3 charge, 3+ charge. Selenide is Se, right?
Yeah, negative 2 negative.
It's always 2 negative? So if you just cross the numbers again,
So it's B2, okay. I thought I was wrong when I did that.
you get V2 Se3.
Okay, so I'm thinking we have to like neutral.
Yeah, but this is neutral.
So that's right.
Yeah, because if you look at it, +3, +3, 2 minus,
Okay, so basically the crossover method already does.
it gives you a shortcut to find the neutrality.
Oh, okay.
So 2, 4, 6, 3 + 3 is 6, it balances, it's neutral.
Oh, okay.
So it has to be neutral, it's always neutral. The crossing method just gives you an easy way to figure out the neutral numbers.
Okay,
It's like, what's the easiest way to find the least common denominator, or find a common denominator? You can multiply times numbers.
I was general.
Alright. Don't you dare say that word.
You said it before.
I did not say it, yeah, but not today.
What word?
Every day is a new day. Okay? Brand new day.
Mom, you did ask a math question.
Huh?
You did ask.
I didn't ask the math question. I made him.
Taken from
You
our
said how do you
class.
find them?
Now you made me say it.
Yep, exactly. That was the purpose. If you have.
No, you're all on your own now. Okay? How dare you? Hold on. Let me just recover here.
Breathe in is not her breathing.
Thank you, Desiree. Thank you. She's right. That's all you gotta do is just breathe in. Okay. Questions. Travis. Then you're next.
So right here, if you just look at, you only guess is 1 for the transition.
You assume it's 1 for transition metals.
And for these, the charge is already there.
Yes. Only if there's no Roman numeral. Kanaya.
As far as the prefixes go with like bi, tetra, and all that, where does that apply again?
With any compound that has no metal. Use prefixes with compounds that do not have metal. So a quick example, There's no metal here. This is phosphorus and oxygen. Okay.
Is it tetraphosphorus?
So this name becomes tetra. This I just made this up. I just made this up.
Hexa oxide, because it was first known as a
I feel like I'm butchering this. No, this word.
Okay. Phosphide. Okay, I have a problem.
Hold on, let me spell this right.
Is that a new rule, Mr. Warner?
Hold on. Hexa, right?
Yeah.
Again, any compound that has no metal in it, you use the prefix setup. You have to use the prefixes.
How come a prefix was used for number 21 when you put copper bicarbonate?
21? Where's 21?
In the front.
What are you doing? I'm in the middle of taking a raise your hand for a question session here. You gotta wait your turn, brother. The bicarbonate
Yeah.
is just a fancy term for hydrogen carbonate.
Oh.
That's another term for if you
That's
ever
kinda confusing.
if you looked up what bicarbonate is, you would get this. Okay?
Okay.
Which is why I wanted to have it on here because bicarbonate is pretty common.
Yeah, I think
I should have put parentheses bicarbonate. That's what I should do.
Yeah, you can do it now.
Well, I don't feel like it. All right, next question off the study guide. Hold on, let's get some new people here. Who? I like the ball. Raphael, you haven't asked one more.
Was the third one or fourth one?
You don't even know what it is.
It's right the one for hydrochloric acid and hydroiodic acid.
Oh, in that chart? Wait, hold on. What are we talking about? Where is this?
I thought you were talking about the warm-up.
Oh, no, we already did the warm-up. We did the warm-up. I'm talking about the study guide. All right, so questions from the study guide. Dean, you're next, Trevor.
Okay, so is that a new rule that was smart?
The prefix rule? The prefix rule?
No. The one about, like, if you have one element that has a charge of negative, like, let's say 2, and the other one has 3, you find the common.
No, all you gotta do is the crossing method.
What?
That's all you gotta do is the crossing method. That's what I've been doing this whole time.
I know, I understand that, but that's. Yeah, because now it's getting.
You're overthinking it. You're overthinking it. So pick one that you've had trouble with on the study guide. Pick one that you look at and you say,
No, because
I can see it's blank. But
after you told me that thing about, I've had an easy time filling in the chart. And then I got to
okay, which one did you
I
get
got
to?
to Fe3, iron 3, and oxide. So I know that iron has a charge of 3, and then oxide is O2, right? O2, and then that has a charge of -2. And then in order to balance out 2 and 3, you need 6, right?
All right, so Fe3 plus.
Yeah.
So, okay, so
You
basically
need 6, right?
number 6, and 6 is a magic number here.
So you wouldn't put 6 at the bottom, you put 3
No.
at the bottom.
Yes. So, okay, so listen. If you do the crossing method,
You get 3 and 2.
you get 3 over here and 2 over here, right?
Uh-huh.
So 2, 3.
No, isn't it O2, Mr. Roy? Oxide?
No? The cross.
No. You don't
Cross.
No, oxide isn't oxide by itself, isn't it O2?
Yeah.
So what you have
But we're talking about the ion here. We're not talking about just oxygen.
No, but look.
Oxide is O2 minus. We're not talking about that. We're not talking about oxygen. We're not talking about that. Is that what you're thinking
No,
of?
but look what I did. Can you just look at this real quick, please?
I think I'd rather not.
Because iron is Fe.
Oxide is just oxygen. Oxide is just oxygen.
And then
Yeah, just one
nitride
oxygen.
is just one nitrate, one nitrate?
Yes.
Oh my God.
All right. I don't blame you for doing that, but you're overthinking it.
I know.
Hold on. Shh. Okay. Travis was next. Hold on.
How would you do like number 2?
Lithium acetate. Okay.
Didn't you do that one already, Mr.
I did one like this.
You did that
He'll be
same
paying
one.
attention. He'd be so busy.
I was in the bathroom.
Yeah, that's true. He was. Okay. Lithium charge is plus. Acetates CH3, COO. The way you know what acetate is you memorize the chart, not mesmerize. You're not going to hypnotize them. You memorize this chart. If you memorize this chart, then you'll know that acetate represents CH3COO minus. Okay? So you look at that, you just get your 1, cross, that gives you Li1.
Oh, yeah.
I keep doing
Stop!
Iodine.
There's your answer. Leroy.
For manganese, nitride.
Manganese.
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 So it's a manganese 4, nitride.
Oh, that's a 4.
Go to 1 already?
Yeah.
4, yeah, 4. And then you keep it.
Hey, no, don't worry like that. One at a time. No, don't worry like that. No. Now you're in the back of the
What
line.
if you can't read Roman numerals? Like on the test, is it like?
Then you better study some Roman numerals.
So on the test, is Roman numerals more than?
Kanaya, what's your Roman numeral number 9?
I don't know.
You gotta know.
Isn't that 6?
Yeah.
Is 5.
Zinc's always
I know, but he said just to put it as +1.
Would that be, you also said 3 and 4?
Yes.
See if I put it as +1.
I'm trying to help you out.
You guys have to pay attention to Mr. Maher, please.
They don't have to.
So,
As long as they pass, that's all I care.
Is that really all you care about?
Very nice.
if it's given, the charge of that, because manganese is a transition metal, so if it's given, we use that number.
Oh, yeah, definitely. Yeah, you have to. That's the whole point. That's the reason it's there. You use this number and you plug it in there. Okay? That's the whole point of Roman numerals, to tell you the charge. Okay? All right, let's get someone who has had one for a while. Kirk.
Number 11 on the front. The front.
So the vanadium 5 fluoride?
Oh, yeah. FeTO4.
On the back. That's the back. That's the
Oh, yeah.
back. That's okay.
I don't have a question about a problem. I just have a number.
This is a good one. This is a good one.
Iron and phosphate.
There's a lot of stuff in the book that I don't think we're even gonna cover.
Cyanide? Oh, I don't know what that is. Because we don't know what those charges
Flip flop.
Phosphates, PO4 3 minus.
Oh, I can't sign
Oh, so we have to
Yes, why do you think I said you have to know the chart? Do you think I said it just to like annoy you guys, or like just to throw something at you? You have to know everything from that chart. Everything! Everything!
I know you have to know the charge before you name it, right?
Yes.
That's +1.
How do you know?
Iron? Yeah, because you said it's not given, so it's
It's not. We weren't given the name. All right, this is a good point. Please listen. Please listen. Kirk brought up a very good point. So, in this formula, FePO4, you have to figure out what iron is, because again, I'm just breaking down the ion so I can get to the name. We're going to the name. We weren't given the name. We're going to the name. I just like putting the ions out no matter what. So 3 minus, whatever. So iron has to be what charge?
3.
3. Has to be 3. If you were to do, yeah, it would have to be 3. There's no way, because you know phosphate is just 3 minus. You have to remember that. The only way it balances out is if its iron is 3 plus, which this works better. If you did the reverse crossing method, you actually would not get the right answer, which is why I
You
hate
didn't
it.
put it in parentheses. I was confused.
Yeah, but it's not
So
always
I
in the
said I put the
parentheses.
4 next to the iron.
Is this a question on this? Because I got to finish this.
it has to cancel out the phosphate.
All right, bell's about to ring. So any like questions I can just comment on? Huh? I don't have time to do another one. Sorry. Yeah, go ahead.
Okay. Do you know like how some like of the endings are like polyatomic ions, like nitride?